Okay, so just a recap of the different methods that you can use for determining which sides you're going to shade with linear inequalities. You can use method 1 when the equation is in slope-intercept form. So if the inequality is in slope-intercept form, then the following holds. So the graph of y is less than f of x will consist of all the points that are below the graph. Okay, so again, when you see the symbol turn this way, less than, it's going to be the area or the region below that you're going to shade, below that boundary line. And then the graph of y is greater than the function consists of all the points that are above the graph. Now okay, so method 2 you can use when an equation is in any form, regardless of what form it's in. To use that test point method, you're simply going to use the point 0, 0, and that's if your line does not cross right through 0, 0. If it crosses through 0, then of course you've got to use another point, but if it doesn't, 0, 0 is the best test point to use because it will give you your inequality statement really quick so that you will be able to determine whether it is a true or whether it is a false statement. And remember, always shade the true side, never ever shade the false side. So let's get started on an actual problem, and all of this will begin to make sense. In this example, we're going to graph a nonlinear inequality. Now, the one thing I notice about this inequality is that the graph itself is nothing more than the parent function y equals x squared, the quadratic function that has been transformed. So let's take a look at what kind of transformations that's took place so that we can use that to graph our line. So recall that whenever you have a number within the function itself, enclosed in the parentheses, that is a horizontal shift. And with horizontal, recall it's quite opposite than vertical. Normally when you see minus 2, you would think that it would be moving to the left 2, but instead with horizontal, this is a shift to the right 2 units. And then in the back, we have a number. Anytime it's in the back, recall that's a vertical shift. If it's positive, you're going to shift it up. And if it's negative, you're going to shift it down. So again, this was the parent function shifted 2 units to the right and then 3 units up. So your graph should look like so. And now that we have our graph sketched, our next step then is to determine whether we're going to shade in the inner or the upper boundary of the parabola, or whether we're going to shade in the lower boundary of the parabola. Now, since this equation is solved for y and in this form, we can conclude that based on this symbol, whenever you have a greater than or a greater than or equal to symbol, that represents that you would be shading the upper region. So we can go ahead and shade it, and it's going to look like so. Now, another way you can determine which region you're going to shade is by using the test point method. The best test point to use is the test point of 0, 0, which is right there at the point of origin, as long as your graph does not go through that point. Now, of course, if your graph goes through that point, then you're going to have to choose another test point. But by far, 0, 0 is the best test point to use because it gives you your values quickly so that you can read your statement and determine whether it is true or false. So let's go ahead and plug in our test point 0, 0. We're going to remove x and y and replace both x and y with zeros. When we do so, it's going to look like so. Let's go ahead and finish simplifying it. On the right side, I'm going to have negative 2 squared. Negative 2 squared is going to be 4, and then 4 plus 3 is 7. Once we get it to where you have one number on one side and one on the other, you can then read the statement. This statement says that 0 is greater than 7. And we know that it's not the same as 7, so we're not even going to read the equal part. Remember, with inequality statements, it's one or the other. Okay? So it is neither. 0 is not greater than 7, and 0 is not the same as 7. That's a false statement. And since that is false, my test point where 0, 0 is, it means do not shade that region, the lower region. Instead, shade the opposite region, which is the upper boundary here. Okay? And there you have it. In this example, we're given an equation to graph. So if you were to look at this equation with an equal sign and not the inequality statement, you would probably be able to recognize that this is the graph of a circle. And in this circle, it has a center at 4, 0 with a radius of 3. So let's go ahead and sketch that graph. We're going to first plot the center over 4, stay at 0, and then extend out 3 units in each direction. So when we do so, it's going to look like so. Okay, so that's over 4, stay at 0, and then extend out 3 units in each direction from that center, and then we sketch our circle. And so now that we have our circle sketch, we have to decide, are we going to shade within the circle, or are we going to shade the outer region of the circle? Well, again, we can use our test point of 0, 0 and plug it into the equation. If when we plug it into the equation, we get a true statement, then that means we will shade the outer region of the circle. However, if we get a false statement, then we're going to have to shade inside the circle. So let's go ahead and proceed by removing the variables and replacing them with 0. So we're going to remove x, remove y, because our test point is 0, 0, and replace them with zeros. When we do so, on the left side here, we're going to have negative 4 squared, and negative 4 squared is going to give me 16 for the left side. We have 9 on the right side. Now let's read the statement. 16 is greater than 9. That is true, and since that is a true statement, the test point area in which we tested was true, so that means we would shade the outer region of the circle, and it's going to look like so. And by the way, the sketching of the circle is a dashed line, because notice with this symbol you do not see a line underneath. And there you have it. And now we're going to graph nonlinear systems of inequalities. So here we have the two systems here, and we're going to go ahead and begin by sketching the first line, which is nothing more than the parent function, the quadratic function that has been reflected about the x-axis. So what we need to do is just to make sure that our y values are the opposite of what the parent function would be. So we're going to go ahead and sketch that parabola. There you have it. And now we have to determine, are we going to shade on the outer region here of the parabola, or whether we're going to shade underneath the parabola. In other words, the upper boundary of it or the lower boundary of it. All we have to do is to plug in a test point, and we can determine which side we're going to shade. So let's go ahead and use a point right here at 0, -2. We're going to use the test point method. I know you can use another method, but we're going to use that method. So that means we're going to remove x and replace it with 0, remove y and replace it with -2. So we're going to go ahead and do that. On the right side, you have -0 squared. And it doesn't matter whether you square 0 or not, or whether 0 is negative or positive. It's just simply 0. So let's read the statement. -2 is less than or equal to 0. Well, we know that -2 is not the same as 0, but -2, it is less than 0, because if you take a look at the number line, here's 0, and then here's -2. Remember, the more you go this way, the smaller your numbers become. So that is a true statement. And since the area where we tested was true, then we're going to shade that lower region there. Okay, it's going to look like so. And that's right in line with the boundary method, which states that when it's solved for y, if you have a less than or equal to symbol or just a less than symbol, that means that you're going to shade the lower boundary. And we did shade the lower boundary there. Okay, now we're not done with this system here. We still have to graph and then shade our second graph. And our second graph is, as you guess, yes, it is still that parent function, but this time with this parabola, it was just simply, it's a parent function y equals x squared, the quadratic function that has been shifted down 6 units. So all we have to do is just sketch that parent function and then shift it down 6 units. So when we do so, it's going to look like so. And notice here we use a dashed line because you don't see a line underneath it, so you use a dashed line. The first one we sketched was a solid line. When you see that or equal to underneath there, you will do a solid line. So the first one again was solid, the second one a dash. Now with our parabola here of our second graph, we need to determine, are we going to shade the upper part or the inner part of the parabola, or are we going to shade the outer or the lower part of the parabola? Well, using the test point method here, actually we can use the boundary method. The fact that it says greater than there and it's solved for y, that means that you would shade the upper boundary of it. But let's just go ahead and use a test point as well to see if we indeed are going to shade the upper boundary just as the boundary method shows us. So we can use our test point 0, 0 because our parabola here does not cross or intersect the test point 0, 0 area. So what that means is in testing this point, if I get a true, then I'm going to shade inside region of my parabola. But if I get a false, then I have to shade outside of my parabola. So let's go ahead and remove the x, remove the y, replace them with 0 and do the math. So on the right side, I can see that all we're going to have left is -6. Let's go ahead and read the statement that 0 is greater than -6. Well, here's 0, and -6 is moving lower, 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 smaller, smaller, way over here. So remember, the more you go to the left, the smaller your numbers become. So it is true that 0 is greater than -6. So therefore, since my test area was a true, that means that we are going to shade in the inner part, or what we would call the upper boundary of our parabola. Now it's time to determine the solution. So recall, when you have systems of inequalities, your solution is going to be the overlapping region. In other words, it's the region that you shaded the first time with the first graph, and then you also shaded it again with the second graph. So as you can see here, this darkened region here is where our solution lies. So if we just take a look at just our solution only, it's going to look, so here is our solution with all the other extra shading gone, and it focuses on just our solution. So recall, solution is the region which overlaps. And there you have it, graphing nonlinear systems of inequalities.